To explain the mathematical framework that predicts the multiverse, we have to dive into the wave function, the core mathematical logic of quantum mechanics. The prediction of a multiverse does not come from a single standalone equation. It comes from taking the standard equation of quantum mechanics literally and refusing to add any extra human rules to them. So here's the step-by-step mathematical logic that leads physicists to the multiverse. The Schrodinger equations. The foundation is the Schrodinger equation, which is the fundamental law of quantum mechanics. In its simplest form, it looks like I h bar here, the partial of the psi here with respect to d equal to the Hamiltonian operator of the psi. So we have the psi function. It is a mathematical function that contains all possible states of particle or system. The Hamiltonian operator, which represents the total energy of the system. So the crucial role here is that the Schrodinger equation is deterministic and perfectly linear. That means if you look the wave function at time equal to zero, the equation tells you exactly what the wave functions will be at any future time. The equation never collapses the wave function. It just smoothly evolves it forward like a river flowing. So superposition and tensor product. Uh, in quantum mechanics, a particle can exist in a superposition as sum of multiple possible states. For example, a particle can be in the state of spin up and down simultaneously. So mathematically, we have this. So you have a so here up and down are basis vectors like x and y in geometry, and the alpha and beta here are complex numbers representing the probability amplitudes. So here's where the math gets interesting in quantum mechanics when two systems interact that their wave function combined using mathematical operator called the tensor product. This one is the tensor product. Okay, so we have the before the measurement. Uh, you have a particle P here that exists in a superposition, meaning it is spinning up and down at the same time. The alpha and beta here represent the probability amplitude, essentially the odds of getting its result. So the measuring device M starts in a neutral state called the ready M. So the mathematics here, the symbol crossed here means the particle and the device are separate as system existing independently. Measurement event, the interaction. When the particle interacts with the device, the rules of quantum mechanics surrounding equation dictates that the two systems become entangled. So the equation evolves into a sum of two states. The particle is up and the device says up. Uh, term two, the particle is down and the device is down and the particle is down and the device says down. So we have the crucial point here. Notice there is no collapse here. In the standard quantum mechanics, the wave function is supposed to collapse into just one result. However, the pure math dictates that both possibilities still exist simultaneously within the total wave functions of psi here, the psi gate here. So the conclusion here is this is the mathematical birth of the multiverse. So because the math shows that both outcomes actually exist as a combined reality, physicists like Gödz Everett, who proposed the many worlds theory, argued that both outcomes are real. So instead of the universe choosing on result, up or down, the universe splits at the moment of measurements. So in branch one, a version of you says the device is up and the particle is up. In branch two, another version of you says the device say down and the particle is down. So in simpler terms, the math says that instead of quantum mechanics forcing the universe to choose one answer randomly, it forces the universe to create a parallel reality for every possible answer. That splitting of reality is what the image calls the mathematical birth of the multiverse.